It's time to wrap things up for the JInventory library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, we finished the GBase and Jiralib, and honestly, I wanted to add something into Jiralib, but I noticed that it's related to inventories, and I thought to myself that, okay, if it's related to inventories, I may want to add it into the JInventory library. However, we have a little bit of conflict here. I prefer to have as few classes as possible when it would come to the block entity types and the block types. If I wanted to add the dropping content to the J block entity or the J block, any one of them, we would have a little bit of a problem there because guess what? They don't have access to the inventory. In other words, the connector actually here, okay? And we don't have access to inventory connector inside Jiralib because Jiralib is the father of JInventory, and we can't depend JInventory back to Jiralib and Jiralib back to JInventory. That would be infinite cycling of dependencies and it will never ever work. So, like it or not, I have to sit back and think about a condition that I need to handle the inventories inside a block entity. First things first, I need to talk about something really important. I got the idea of the library, fluid, and energy inventories and containers from Turti Vorti's streams and then looked into his repository and, compared my own implementation to his, and I found that he is doing a better job, so I'm getting it from there. However, he had started using something called components. Now, this is not the components that you see inside Minecraft. That is something else. He was implementing his own component system, and his own component system was something that at the start looked promising, but the more I thought about it, the more it became obvious that it was overcomplicating things. I mean, when it comes to inventories, all we have and all we need to have is a list of item stacks, because no matter what we are doing at the end, the bottom line is that we are having a list of item stacks and we are playing with this list one way or another. So all we have to do is to give ourselves an easy way of hooking this list of item stacks into any block entity that we want, into any screen handler that we want, and have easier life doing that. By adding those components, we were overcomplicating something that we could do it in an easier way. If you look back into the block entities that we have inside Jiralib now, you will see that I only have a G block entity and it is already updating, ticking, and syncing itself. So it's a complete block entity. And if I want to have a screen payload, then we have the G screen BE on top of it. If I'm gonna do something as simple as updating, ticking, and syncing a block entity, then why should I overcomplicate things by adding an extra layer of abstraction for the components and saying that, hey, anything that has the component now should be updatable or should be syncable? That doesn't make sense, because at the end, the only place that I will use that component would be the inventory connector itself. And the inventory connector is the concept that needs to be synced and updated inside any block entity. So I'm already having the inventory connector, and this inventory connector is already handling lots of things like, I don't know, getting the slots and covering everything related to an inventory actually. Also, if I need to, I'm handling the reading and writing the NVT, although I may come back to this and compare it to my own code and make sure that it is already working in the new versions of Minecraft. However, that's it, this is all about it. And by having this, I don't need another abstract layer of overcomplication for having components. That's one thing. I'm dropping the idea of using components. And I think Turti had came to the same decision, because if we take a look at his repository, we would see that he had already dropped continuation of using components. And actually, I can show it to you. This is Turti's repository, okay? As you see, he has this component and then component container. And on top of that, he has 4 components. However, to use them, he started this inventory builder, industrial simple inventory. And this industrial simple inventory is the main entry point to the whole inventory system in Turti's library. Now, guess what? None of his block entities is using Industeria simple inventory. Nothing in this repository is using Industeria simple inventory. So it looks like he started implementing something and then he noticed that it's overcomplicating things. So he made the decision to drop them. But when he dropped them, here's the thing. He didn't go back and clean his repository for whatever reason. Now, if you want to wrap things up for the JInventory, I will start exactly with inventory connector because I want to make sure that my read and write NBT is actually final and working. So for writing the NBT, we are getting the NBT and then we go into the inventories and we'll look through them and we say we want an NBT compound. Then we add the write NBT to that compound and we return the NBT. That's correct actually. The read NBT is the section that we may have changes from the 1.21.5 and we are looking through the size. That's correct. We get the NBT by using NBT get compound or empty for the index. And if it's empty, we continue. Now I may comment this line. Wait a minute. Let's continue forward. Then we get the inventory that is at the index. Then we read the NBT on the inventory held stack with the lookup. That's correct. Everything is correct. However, I'm not sure if I want to keep it or not. Let's remove this. And this will be the final result of our connector. We were asking for an updatable BE. Now, guess what? We have changed it to being either the G screen BE or G block entity. Now, the parent of all of that is G block entity. And I will use that one. Although normally when you have inventory, you would want to have some sort of screen to just handle the showing of things to the player. But right now I'm preferring to go back all the way to have the base. Now, the only problem here is this one. Copy it, we paste it, but instead of mapped direction, we get the direction. And here, instead of all of this, I will say this.add inventory with the inventory, map direction from direction side, can insert and can extract. And hopefully this will solve the errors we had below. Yes. Okay. Add insert only and extract only overloads using direction. I just added them. This should be the final thing. Okay. Now we have few errors in the import. Yeah, updatable B is not there anymore. And this is our inventory connector. Believe it or not, that's all there is to it. And finally, the NBT things are finished. Let's continue forward. The next thing that I want to change inside this JInventory is the name of these four inventories. Everything that I have inside JInventory is an extension of simple inventory. But take a look at that. Output simple inventory. Well, I don't like that name. Why not go with output inventory? What's wrong there? And predicate simple inventory. Why not going with predicate inventory? Recipe simple inventory. Well, let's go with recipe inventory. And finally, synced simple inventory. Okay, synced inventory. And that's it. That was the next one. Now for the record, I should be okay there. Now, this is exactly one of the things that we should drop because the idea here was that this record would be used for the inventory builder. And as I said, we don't follow that road with 30/40. So I will drop this predicate inventory storage. Now, the next thing is that other than the slots, we are okay with the slots, I think. Limited tag slot, not tag the slot, output the slot, predicate the slot, tag the slot. We have a problem here. Add inventory. What's wrong with you? Predicate inventory storage. Oh, god damn it. I didn't take a look at this one. Yeah, this is the heart of everything. Okay, let me get back that. And now we should be golden. Yes, so I forgot that we are using that predicate inventory storage here. Okay, so as you see, we are using the predicate inventory storage from the records, so we can't delete that one. Now, as far as I can say, the slots are good. Something that I would like to have is that these slots could accept the number of items in them. For example, the predicate slot could have a max count, you know. So I would say private int max count. I will have another overload that says we have the inventory, yeah, the index, and then the stack. But before the stack, we get int max count, and we go with actually not the super with this dot comma predicate, and then we say this dot max count equals to max count. Now on can insert, I will have another condition. I will say if max count equals to 0, then only test the predicate. Otherwise, check that the predicate is okay, and no, we don't go with the super, but what we want is that let me think about it. Get a stack dot get count should be smaller than max count. Okay, this way I will have a new way of implementing our predicate so that if we want to, we can add a limit on the number of items that we want. Then let's see our problem here. We say predicate slot with simple inventory index xy, and we go with this inventory xy. The predicate would be stack goes into inventory dot is valid for index and the stack. Cannot resolve symbol inventory. Well, I'm not sure what was wrong there. I just copy pasted the whole thing again, and it's okay. I think I had a typo on the inventory. Let me see. Yeah, here inventory. Yeah, it's inventory. So it's a typo there. Okay, so inventory that is valid is the correct thing. Now I have another copy of this that accepts the. Now where do I want to have this count now? Yeah, at the end max count. So this would be the max count, and this will not work, will it? Because we have int index xy. No, actually we need to remove that part. Then we say this dot max count equals to max count, and that should solve that one. Okay, so this will hopefully call this one. Yes, correct. Good. Now our predicate slot became better, and because of that, now I can go back inside each one of these and add another constructor that will accept int max count. And here before the predicate, we send in the max count, and it should work. Yes. Then no tag, same deal, copy, and before the tag key, we go with int max count, and again before the predicate, we go with max count. The output slot, well, this will return false all the time, so it doesn't matter. We don't need any max count there. But the tag, the slot, we say int max count, and before the predicate, we want the max count. Now, I was thinking about having another one, and that would be to accept a list of items, and it is not tags actually, but the concept is similar. So instead of getting a tag key, we would get a list of items, and we would check that if the stack is actually inside the list of items. Let me do a test here fast. So if I add a list, yeah, I thought so. Here we should change things and say tag keys dot contains the object, and here we say item stack dot get item, because that's a list of item there. Now what is the problem there? Cannot result get item? What the heck? Okay, so that would work actually. Now just we change this one to list and list, but I'm not sure if this is useful or not. The example usage would be like this. New, okay, let's see, var slot equals to new tag the slot, because we have it here. And here we say the inventory, then the index, then the x, then the y, then the list of. I don't know, for example, mod items dot some item, comma, mod items dot another item, and so on and so forth. So we can say that, hey, for example, we want a list of gems, and it would be either the ruby gem, the sapphire gem, or the, I don't know, something else. But these are the only ones, and I don't want to create a tag list for them, because let's face it, when you have a tag list, modpack developers want to use it. So do I want to go into this pit hole, into this rabbit hole? I think I want to. So I will add another class and call it listed slot, and it's the same deal actually. It's extending the predicate slot, and I will cut this one. I will paste it there. This is all we need to change, and then another overload, and we want int max count. And again, before the predicate, we send in the max count. Now I will not go into another deviation from this. For example, if it's limited tag or not tag a slot, because in this particular case, we want a slot that accepts a very dedicated types of items, very few of them actually. And on the other hand, we can go with not containing some special items. So not listed slot, maybe. Java class, not listed slot, it's the same thing. Actually, I will not even bother doing anything else other than copy pasting. And all I'm gonna do, I will negate this part, putting a not in front. So that's a not listed slot. Now, doesn't make sense to have something like the limited tag, because limited tag says that, hey, I have two tags tags, I want it to be inside one tag and not in the other tag. Now, if you're providing lists, well, I can't see why someone would put something like an item inside two lists, and it's finished on the slots. I can't think about any other way of having it. Okay, so inventories are done, slots are done. Now we have this screen handler that we need to handle, and of course, now I have to finish the GUI before going back to this. God damn it. Okay, however, let me see. Yeah, I need to finish GUI before this one. So we are not finished with JInventory, but we can do something else. For example, the block entity and the block. Now, why do I have a block? Because as much as I think, we don't have anything to do with the block anymore. I had to have the block because in 1.21.4 and below, we had to break the block here and drop the content here. But now we don't have it, so bye-bye to that. But the inventory is something else. So this is synced, and I will go with a G block entity and not the screen one. Now this is the heart of everything that I need to add again. First things first, we need to have our inventory on top, okay? So we will have a connector that connects to inventory. So we say protected final inventory connector. Now this is asking for a type, and I will give the type because it's the same thing. Actually, no, I think now we have a problem here. Yeah, we have a problem here because I'm not sure what type of inventory we will send in here. Yeah, that would be a problem if I don't introduce another generic. So let's go with this. Let's add that generic, but here we will use that B, and B should extend inventory. Okay, so inventory connector, storage connector. Oh, it's simple inventory. Okay, simple inventory. That should be okay now. And here we call it inventory. We need to immediately make it being constructed, or actually we could make it inside the constructor. In this particular case, let's get it from here. Let's put it here and let's remove the inline construction. Now that we have that, we need to say this dot properties dot is sync. That's one thing. Let me see, what else do we want? Yeah, we go with is updatable, then dot is sync, and what? No. Update. Okay, and then sync. And when we are syncing that, then we should say state or actually wait and tick for the syncing. Okay, so this is everything that we want. We just left the tickable ability of the block entity out, and we are not adding anything to the tick logic. So in other words, any children of this class will call the super, and these things will happen in super. So then it only needs to say if we should tick or not, and what is the tick logic. That makes sense to me. Now here's a question. Do we want to make this one extend the screen, or we want another copy of this that says J screen inventory B? Okay, let's do the J inventory first. Now after the constructor, I will say public void add output inventory, and this will be int size and mapped direction. The purpose here is that we can call it from our children's constructor and immediately add as many output slots as we want that are bound to a single direction. So we say inventory.add inventory, and here we want an inventory, so new output inventory, and here we need the block entity, that would be this, and the size. After the add inventory, we need the direction, that is the direction. Now what is wrong with you? It says updatable. Well, we have problems there. We didn't fix those. Oh, okay, because these are not there anymore. So G block entity, and same here, and then we go down the rabbit hole. So here and here, down the rabbit hole. This one is okay, so that's fixed that one. Okay, here we go. Sync is not iSync anymore, it's iSyncable. And get syncables list of this, so I need iSync and iSyncable. And here should be list of iSyncables. This one is block entity. Get word, assert that word does not equal null. And instead of this dot block entity get word is client, we can say this dot block entity dot get. Do we have properties? Oh, we don't have access to properties. Okay, well, here is the funny part. Has word is checking if the word word is not null. So we are already doing it, but unfortunately, IntelliSense is not smart enough. So we say suppress for statement. That's that. So this will sync the inventory, and get syncables returns this one inside the list. Now, do I want to have that one? It doesn't make sense actually, So we will remove this part. It doesn't make sense because this is a syncable, not a syncing block entity. That and that. Okay, we don't have the list anymore. So the recipe inventory is happy now. The predicate inventory is happy now. So we have, again, wrong inputs. Okay, now here's the thing. Output inventory, I said that it needs inventory BE. I don't like this. I seriously don't like it because I want to go back all the way to being JInventory BE, be the G block entity. So if I remove that part and use a wildcard there, going back there, we don't have any problem. As I said, I'm not sure what was the problem here. I just removed this and retyped this, and now everything's working. So be that as it may, finally we have our add output inventory that will add an output inventory with as many slots as we want in the direction that we sent in. Then we want to get the connector. So we say public that returns inventory connector of type B, and we call it get inventory connector. This will return the inventory as it is. Then we want to get the read and write NBT. So we say read NBT and finally write NBT. Now for the read NBT, we call the super first, and then let's take a look. The super is doing nothing there inside our G block entity. We are doing nothing in the read and write NBT. So the super is not relevant. So let's do the write first. We say nbt.put, and here we want a mod ID. Let's go with JInventory dot, and then we will add something from our base library. Let's go into the constants of IVals. Forget that this is BE keys, not constants. So BE keys dot has inventory. Okay. And then what we want to write is the codec or NBT element. Now, thankfully, if I call inventory.write NBT, you see that it returns an NBT list. And NBT list is actually NBT element. So all I need to send in there is the registries. Now, for the read, we go with saying that if NBT.contains the same key that we want, then all we want to do is say inventory.read NBT. And here you see that we want a list. So we say nbt.get list from the key. Now guess what? The key is the same thing that we had. And after that, it's an optional. So we get the get. However, we want to send in the registries. This is the registries. Now we will have a warning here that says it may be null. And because of that, to get rid of that warning, I will open it this way. And we will say that, what list equals to the nbt get list until before the get. Then we say if list.is present, then please use the list here and do the get on top of it. Now it says that replace optional presence condition with functional style expression. Click on that. You see that everything is changing. You get a lambda here, and this is basically the same thing. You check if the list is present, then you get nbt element there and inventory read element blah. So this will work, okay? And if you want to, you can remove that list because it is being used only once here, and go with a one-liner that does the whole thing. And of course, now I will break the if present to the second line, and this is our read NBT. Now, if I want to go with the screen handling stuff here, I can. The question is that would we have any sort of block entity that doesn't want to show itself in a GUI? And I'm not talking about my own mods. I'm talking in general concept. As a general concept, I would say yes. Things like refine the storage or any one of those storage mods actually will eventually have a block entity that contains an inventory, and this inventory will not produce any screen. I don't know. As I said, I don't like to have yet another inventory block entity just to add that screen stuff when I can simply say that this is G screen BE, and I will accept a C, and I will say C that can be anything, and I will say T and C here so that it has the second param, and then I will have to add the methods like get a screen opening data, get display name, and create menu. I will have them, then I will remove two of them later, but here I want the screen opening data that returns a new block pause payload, and this dot pause. Now what's wrong with you is that I don't need C. Actually, I just need that. Or I don't even need that one, So I will remove that, and this is block pause. That's it. And that should work. Then for the display name and create menu, we won't have any one of them. To get rid of the errors and anything else, we know that this class is abstract. And because this is abstract, now I can remove the create name and display name. And that would be it. However, we have another thing to add. Actually, we need more than one thing to add. And we will start with some interfaces. Now, I will add interfaces. One of them is already implemented. So let's add the package called interfaces. And one of them, as I said, is already implemented. I will just say JInventory connector. Now, all the JInventory connector is doing is this. It will return an inventory connector. Okay, so it will accept T extends simple inventory, and it will just return the T get inventory connector. So here I will say this implements the JInventory connector of type B because we already have that. And as you see, it will work because we already have that get inventory connector that returns inventory connector B. The other one will be called iContent drop. Okay, now iContent drop needs again T extends the simple inventory, and this will extend the JInventory connector of type T. Okay, here we will have a block, and we call the method get block. Then we have a default method called drop content. Now drop content will accept a word, we call it word, then a block pause, we call it pause. Here we want to get the inventory and then do drop contents on the inventory. So we say inventory connector of any type, and we call it inventory equals to get inventory connector. Now that we have it, we say if inventory does not equal to null, then we say inventory dot drop contents on word and pause. Finally, we say block equals to get block, and we check if the block does not equal to null. Then we say, word dot update comparators for the pause and the block. This will update the comparators. However, if you recall, we have something that is doing this for us inside the G block. So if I go with G block, you see that when we are changing the state, we are just calling on item scatterer on a state replaced, and all it's doing is updating comparators for the block, okay, on the pause and the block. Because of this, I think when we are calling this drop content, we already changed the state. Do we want to call it here? Because this will be called from the block entity side of things, not the block side of things. I will remove that, and that means that I don't need to have the block on top, okay? By the way, this is one of those classes that came by 3040 that I'm nuking part of it because of the logic. So that's that. Now we have the interfaces. So let's see. iContent drop needs to be part of a block entity. So JInventory BE, instead of JInventory connector, I will go with iContent drop of the B, and remember B is our simple inventory, so that would work. And because it's extending the other one, so I'm already having get inventory connector thing. This will handle the drop content injection into our block entity. However, here's a question. When we will call that drop content? Right now, nowhere. So I need to override another part on block replace. Now take note, we have on block replace, but we don't have on state something. On block replace is the new way that you should handle the breaking of an inventory inside 1.21.5. Previously, we would do things on the block entity and on replace state, but now things move to the block entity, and that makes sense actually, because when you are breaking a block, well, you just break the block, but the content is inside the block entity. So this will encapsulate the functionality inside the block entity correctly. Now, unblock replace. We don't need to call super because I assume that super is doing nothing. Let's see. It's going into abstract furnace block, campfire, jukebox. Let's take a look at abstract furnace block and unblock replace. It's calling super. This one is on block entity, and oh, the block entity one is doing the spawn on the inventory. But here's the thing. It says if this is instance of inventory, basically it's checking if the block entity is directly implementing the inventory. Then it will do stuff there, and in the fairness, we just get the word and says get recipe used and drop experience. Now this is interesting. I may want to add it somewhere. So let's take this one and keep it inside the code here, but I will comment it. So we don't want to call the super. The reason is that our class is not directly implementing the inventory, not at all. Now we need a block reference, and for that I need to somehow assign a block. We get the pose. So let's see, we say if we don't have the word. Oh, we have the word. Okay, dot get block state at the position instance of G block, and we call it block. If that is not the case, then please return. And what's wrong with you? Oh, dot get block. Yeah, and get block state, what's wrong with you now? Assert word does not equal null. Okay, if word equals null or that, return. Now that we have the block, we say if block dot drop, should drop items on explosion. No, that's not what we want. We don't have access to properties on the G block, do we? I never thought that I would need to get access to the properties outside of G block. Okay, I need to encapsulate this. Let's see. It will be public that returns a boolean, should drop content. It will return this dot properties dot has inventory, and instead of this, actually, this is making me confused. Why should I even have this? Because if I'm adding inventory to the block entity, yeah, let's have it. Should drop content has inventory. Okay, let's go with has inventory, and then we say block dot has inventory. Now we don't have this because I need to push the Jiralib into the Maven again. This is inside Jiralib library, but that will work. So if the block has inventory, then we need to do things, and here we say if not, the old state that is of the word dot get block state at the pause, and finally dot get block. Yes. If that's the case, then we have replaced it with something really different. This is when we go if this instance of iContent drop, and we call it BE. Finally, we say BE dot drop contents on the word and the position. Now, what is the problem here? It says unwrap if it's extracting side effects. So we are directly, okay, we are sure that this is, yeah, because we are doing it inside the same class. Am I dumb enough? So there we go. This dot drop content. And remember, this dot drop content means that we will go into this thing and we get the inventory and call drop content on the inventory. Drop content on the inventory is going all the way back to this inventory connector, and we go for each inventory inside our list and to the item spawn. Okay, that will work. So far, so good. Now, the only problem is this has inventory is not recognized. Okay, I want to add something to our properties, and I'm not sure if I want to add it on top of the BE properties or the block properties because it's related to dropping the experience, Now, this get recipe and drop experience. Okay, let's remove it from here because it's irrelevant to inventories anyway. We will dive into that when we are handling machines. So I made the decision that I need to have a screen for every block entity. Now, keep in mind, if you don't want the block entity to have any screen, then just ignore the extra methods that you need to override and leave them empty, especially the create menu, and don't register any menu for the block entity. We have something else here. Remember, we want to make this sided, and we already have we don't have the provider here, do we? No. Okay, guess what? Another Java class, JInventory provider. Now, JInventory provider is an interface, and it has two different methods. All of them will return inventory storage, and we call get inventory storage. However, this one needs a direction, and the direction, yes, comes from there, and that would be the only method there, JInventory provider, and we get it and we implement it here, JInventory provider, come on, and then finally we need to address this guy. So public inventory storage of that, all we need to send in, we say this dot get inventory storage for the direction, direction. And that should work. Now what? And we'll return it. Now what's the problem with you? It says method get inventory is recurses infinitely. Oh, we are calling ourselves. Okay, let me see. We have the inventory connector. We need the, whoa, what I'm saying. We need the inventory and then get a storage, inventory storage, yes, of the direction. That's what we want. Okay. Now, do we want a mapped direction? No, not really. This method is related to the registering for the sided. However, you know what? I will add it because who knows what we will have. So I will have another overload for this that uses mapped direction. And here I will say copy paste. This one is mapped direction. And again, the whole thing will work because we have overloads on the inventory connector. And this will handle the sided inventory registration for us. This is an overload that we can use if we want to ourselves. Are we done? Inventory connector, predicate key. Do we have any usage for this guy? Yes, here I think predicate key equals to that. Yes, we are using it. Okay, so that is our base. Then we don't have any block, thankfully. Oh, we have a screen handler to cover. Okay, but as I said, I can't attack this guy unless at least I get the GUI up and running and push a little bit into the Maven repository as temporary solution so that I get my hand on abstract screen handler, because we need to move forward from there. However, I think we have another thing, and this is interesting one. Yes, I forgot about this one. We will say client inventory connector. Now this one extends the inventory connector, and as you recall, we need inventory connector to be of the t extends simple inventory. So we will say t extends simple inventory, and here again inventory connector of type t. Okay, now this class will have a method, and we say public static that returns client inventory connector of type t, and we call it copy of. Here all we want to send in is an inventory connector of type t, or actually of any type, and we call it inventory. And inside the method we say var storage equals to new client inventory connector. Then we say for pair of direction, comma, anything that extends simple inventory, we call it entry, inside the inventory dot get inventories, or actually get sided inventories, yes. And what is the problem with you? It returns a list of pair of mapped direction and t. Okay, so this is mapped direction, sorry. Now that we have it, we say storage dot add inventory, the new simple inventory with the entry dot get right dot size. Now let me see what's problem here. I will fix it, but entry dot, oh, I think this is change the name, get A and get B. Okay, this is get B, this should be get A. Actually, what is the problem here? No, this should be B, this should be get A. Yeah, that's it. So what is the problem? It returns, oh, wait, we didn't return it yet. Okay, so at the end, we return the storage. Okay, now we have a problem here. Storage is client inventory connector of simple inventory. Now instead, say T, it will not accept that. Let's see, fix this make copy return block. Okay, that will work. So basically this one is actually converting any custom type to a simple inventory and return a copy of it. It means that, for example, if you have an inventory connector of the type of, I don't know, output inventory, then we will have a way to convert that to an inventory of simple inventory and get a new inventory of simple inventory. I don't see what would be the practical usage of this, but I had seen it inside Turtywörty's library, so yeah, I may want to keep it. Now this one is not Turty's thing, it's mine. So let's get it from here and let's add it on top. This is mine. The inventory provider is already mine, yes. Then the content drop, actually the client inventory is belonging to Turtywörty. And did I tweak anything here? Yes, I had to use the generics here, so that's okay. Inventory connector and the BE and finally this one. This one again is mine. However, as I said, I'm not attacking it until I get the GUI up and running. So you see that we have errors here. One inside the screen handler, of course, but one is inside the JInventory because this one needs the Jiralib to be pushed to Maven. The pushing of Jiralib to Maven will happen between the videos, and in the next video we will come back and we will start working on GUI. Now right now GUI is nothing big and it won't be big enough to be really a dedicated library. However, I have some plans for it in future, so I'm keeping it as a dedicated library for itself, and we will see what will happen next. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.